I'm back again. You thought you were done with me, but we've got a little more review to do. I wanted to also review multiplying and dividing fractions. Like I was telling you in the other video, this is so much easier than adding and subtracting. I'd rather multiply and divide fractions all day long than have to deal with any adding or subtracting of them. When you're multiplying, the big difference is both numbers are going to change. Both the numerator and denominator, both the top and the bottom are going to change when you multiply. Okay, because you multiply straight across. All right, so 1 times, the problem is 1/2 times 3/4. So it's 1 times 3, that's 3. 2 times 4, that's 8. And then, like all fraction work, you got to look at your answer. You got to ask yourself, can it be any simpler? Is it in proper form? And I can only divide 3 by 3. Okay, that's called a prime number, where you can only really divide it by itself in 1. So I just look at this, and 8, I can't divide 8 by 3, so I'm good. That's my answer right there. All right, let's go over a little bit here. 5 times 4/6. So you've seen these before. We got that whole number, and that kind of messes us up. We got to have fractions to be able to multiply by fractions. So I got to ask myself, how can I make this into a fraction? And there's a lot of crazy stuff I can do to make it into a fraction. But the thing I got to remember is whatever fraction I make it into still has to be equal to 5. I can't just like put it over, 7. I can't just put a 1 over it or anything like that. Whatever I come up with, it has to be equal to 5. So really the simplest thing you can ever do when you're multiplying or dividing fractions is just put it over 1. Because remember, a fraction problem is really sort of like division, right? So it's always top divided by bottom. Well, 5 divided by 1 is 5. So even though it looks different, even though it's a fraction now, it's still equal to 5. It's still the same number, just looks different. All right. Going back to our pieces sort of thing, it takes one piece to have a whole, and I've got 5 pieces. Well, I've got 5 whole numbers. I've got a 5. All right, so once I've done that, and then I'm back to easy peasy, I just multiply straight across. 5 times 4 is 20. 1 times 6 is 6. Oh, but hold on, heaven's sake, look here. All right, so we've got a number that can both be reduced and that is improper. The top's bigger than the bottom. Different ways you can do this. I like to reduce first because then the division's a little easier. So I'm going to look at this. I'm going to say, well, they're both even. So I'm going to start by dividing by 2. Half of 20 is 10. Half of 6 is 3. All right? And I know, again, my 3 is a prime number, so if I can't divide the other one by it, then I'm done. So I'm done as far as reducing goes, but it's still improper. I cannot have a bigger top than bottom. So I'm going to divide it out. 3 into 10. 3 goes into 10 3 times. That's 9. I subtract. 1 left over. 3 remainder 1. The way that looks when I go to make a fraction, okay, this is going to be a mixed number. The 3 always represents my whole number. So I got a big 3. The remainder always represents what's left fraction-wise on top. So I got a 3 and 1 over, well, remember, this is division. What was I dividing by? Yeah, I was dividing by a 3. So 3 and 1 over 3. And that becomes my final answer. All right, let's look over here at this one. All right, now we're dividing fractions. Okay, so there is no such thing as dividing by fractions. All you can do is multiply by the reciprocal. The reciprocal is a fancy math term that just means the flip-flop. So as I'm reading this problem, it's 3/4 divided by 2/7. And I'm always going to be flip-flopping the one I'm dividing by. So I'm going to change this up. 3/4 times the reciprocal, which is 7/2. Okay, I multiply it out. 3 times 7 is 21. 2 times 4 is 8. Okay, I got a situation like I had on my last problem. I had to first see if I can reduce it, which I can't. So if I can't, I just got to divide it out. So 21 divided by 8. It goes in there 2 times. That's 16. I subtract and get a remainder of 5. So again, my whole number there is going to be a 2. And then my remainder goes on top of the fraction. And the bottom of the fraction is what I was dividing by. So I got 2 wholes and a 5 left to be divided by that 8 that I just couldn't do anything with. Okay, that 5 is still being divided by the 8, but there's nothing we can do there. It doesn't go in evenly. All right, let's look at this one. Okay, same thing. I got to have fractions when I'm multiplying or dividing. So that 5, that's a little bit annoying. I got to do something with it. Well, it doesn't matter what number it was. It's the same process. I'm just going to put it over 1. So this problem reads 1/8 divided by 5/1. So I'm going to, again, multiply by the reciprocal. We're just flip-flopping that. Then you multiply straight across. Okay, 1 times 1 is 1. 8 times 5, that's 40. 1/40th. And there's nothing I can do with that. That is the final answer. All right, down here. So we got 4 divided by 6/9. Again, we got to make that a fraction. So we're going to put it over 1. There's no such thing as division of fractions. We got to multiply by the reciprocal. So this is the one we're dividing by. So that's the one that gets flip-flopped. So 4 over 1 times, now it's going to be 9/6. I flip-flop it. All right, 4 times 9 is 36. 1 times 6 is 6. I got to divide that out. 36 divided by 6. Oh, I look at my chart and boy, hey, that's perfect. It goes in there 6 times exactly. 6 times 6 is 36, nothing remaining. So I've got no remainder. All I got's a whole number. So my answer here is simply 6. All right, these next ones, you're not going to see them today, but they're coming up. So I wanted to give you a preview here. All right, what if we had a mixed number when it comes to multiplication? Well, again, when you're doing multiplication and division, you really need to be working just with fractions. You got to figure out a way, how can I make that just a fraction? So we're actually going to make it an improper fraction. We're going to turn it into an improper form so that we have just a simple fraction. All right, the way we do that, we times it by the bottom, then we add it to the top. All right, times it first, then add it. 6 times 3 is 18. 18 plus 1 is 19. So 6 1/3 is the same as 19/3. And if you look at it, we can reverse the process by dividing it out like we did on the other problem. 3 goes into 19. Well, 6 times 3 times 6 is 18. We subtract minus 1. We have 6 remainder 1. Well, that would be 6 and 1 left to be divided by the 3, right? Just like on our last problem. All right, just wanted to prove that for you so you understand. So times it by the bottom, add it to the top. So we got 19/3 times 2/5. Okay, 19 times 2. Let's see, that's 2 less than 20 times 2, so it would be, what would that be, 38. And then 3 times 5 is 15. Oh, it's improper. I got more work to do, but it's not too bad. 38 divided by 15. 15 can go into 30 twice. I know that for sure. 15 times 2 is 30. Subtract it out. We got 8. So remainder 8. So my final answer is going to be 2 as a whole number with 8 left to be divided by, oh yeah, that's divided by 15. One final example. Now we're doing division. It's the same thing. I got a mixed number, cannot deal with that. So I times it by the bottom, I add it to the top. 2 times 4 is 8, plus 1 is 9. So I'm going to have 9/4 divided by 3/4. Well, can't divide. What I can do is multiply by the reciprocal. So 9/4 times 4/3. All right. So again, remember, it's always the one you're dividing by that you flip-flop. So I was dividing by 3/4, so now I'm timesing by 4/3. Okay, I multiply straight across. 9 times 4 is 36. 4 times 3 is 12. Oh, I got an improper fraction. Got to divide it out. So 36 divided by 12, it's always top divided by bottom, forever and ever and ever when you have fractions, top divided by bottom. If I look at my chart, this answers pretty quickly because if I go down my 12s column, 36 is 12 times 3. So 3 times 12 is 36. I subtract, nothing left. I just have a whole number answer. No mixed number for that one. All right, I hope that helps a little as you start on today's assignments and get back into the groove of working with fractions. We got one more video you're going to see later on where we talk about negative numbers.